sorry, just 1 second. Just let me tell you what is dark matter. Dark matter just the matter carry light. Okay, I have not tell you what is carry light, because I said the entire universe is made by just one magnetic particle. So this fundamental magnetic particle is the same particle. Fill the entire universe. Fill the entire universe. And this particle is a magnetic particle, so of course it will have a magnetic force, right? It will create a gravity force. But why this force this particle we cannot detect? It's billions and billions smaller than electron. Okay, so you know, everything we know, known particle, other than electron, we can detect on Earth. Anything smaller than electron, that's a neutrino. The only thing neutrino. We cannot detect neutrino in laboratory. Only have to be giant, Earth facility, and still independent. Okay, next. Okay, thank you. And then dark energy. What is the dark energy? In modern physics, energy and mass are two separate things. In my theory, energy is just the motion of particle. The particle has mass called a mass of particle. So if you find out there's an extra 5 times of the matter, and all the matters fill out the entire universe, and so tight at the elastic range, this universe will expand. How? Because we know the star exploded. They turn solids, dump all the solids particles into this already saturated with particles in elastic state. I will talk about it in the lights. So that's why you already elastic. You dump more. You pour more, say, water into the cup. It's over spill. It will expand. That's the force. So there is no what is called the dark energy. The dark energy is just a motion of the so-called dark matter. Okay, so this page I try to demonstrate. Okay, can you click the video on this page? Yes.
Here is data. Here are data, whatever you want to say. We know that the standard model of particle physics is not the end of the story for the universe. Here is data. Here are data, whatever you want to say. We know that the standard model of particle physics is not the end of the story for the universe. We know that because the standard model of particle physics makes up what we call ordinary matter. It explains you and me and the table and the air and the sun and the moon and the stars. It does not explain the universe. Because we can map out the gravitational field of stuff in the universe, and we see pictures like this. This is a map constructed by looking at the deflection of light through galaxies scattered throughout the universe. We can basically weigh the universe. And what we find is there's a lot more stuff than we can possibly account for than in the standard model of particle physics. We call the extra stuff dark matter. It's not quarks, it's not electrons, it's not neutrinos or Higgs bosons. It's something absolutely new. So we can't be done with particle physics. There's some new particle called the dark matter particle, or maybe 20 new particles called the dark matter sector of many different particles. We don't know yet. We're looking underground for dark matter particles to bump into things. We are also trying to create dark matter or other particles associated with the dark matter at the LHC. So it's absolutely clear, not just a wishful thinking kind of thing, that there must be new physics out there. The LHC is on the mark to try to search for it. We'll have to see if nature is kind or a little malicious to us. Here's
evidence of yuan. Next one. I just want to demonstrate that this is maybe benefit for people. I always thought whoever who invented microwave should win Nobel Prize. This is such amazing things ever. Include the gentleman invented called infrared, this remote control. They are incredible, practical value added to modern society. If you wanted to know what's driving microwave, is nothing more just alternating magnetic field. That's all the microwave do. And what happens to the stuff you put inside a microwave? Almost everything were warm and even spark. You know the reason? Everything made fundamentally is magnetic particle. Magnetic particle will respond with an alternating magnetic field. That's how food was warming. And there is one very interesting phenomenon I saw. The first time I saw it is amazing. Is if you look at it, they put a light bulb in the microwave, light bulb lit up. This is a totally counterintuitive. When we learned electricity, everything has to be a closed circuit, right? Closed circuit in order for electricity flow. There is no flow here. So what that means, that tells me what is the nature of electricity. Electricity is not really called a flow. It's not truly called the flow of charged particle. It's oscillating magnetic particles. Magnetic particle is oscillating, you will generate a magnetic field. Let me give you an example. We know in the old time battleship, there's one genius use all the mirrors, try to, burn that battleship over hundreds of yards away. Use all the mirrors, focus the lights to burn that ship, burn a hole, and so destroy the enemy fleet. What's the reason? Because the light is carried by magnetic particles. Light is a wave. So when you focus all the light in very small area, so that magnetic particles in that were high vibrations, create high vibrations. Once you concentrate enough, of course, the particle carry light is billions of times smaller than electron. Okay. So if you have an electron impact, you will see huge sparks, right? Lightning, everything, huge spark. But in order you make such smaller particles together, generate huge energy. So that's why they have to use lots of mirrors, layers, top, bottom, and concentrate to one point. And so confine all the small magnetic particles vibrating high enough to burn through the battleship. That's basically tell you the people, we use this technology all along, we just do not have enough explanation. Okay, that's enough for this. Next one, please. This is, I try to provide evidence. What is the evidence of, I was said called a UON, universal particle, okay? This is another, this is the evidence, the latest, this chart cost $9 billion for the people at CERN. This is called the Large Hadron Collider. To generate this, just two charts. These two charts was used to demonstrate the existence of God's particle. Where is the God particle? It can never be measured. It cannot be seen. Okay, cannot be measured directly. The only thing they said, the God's particle is this two little bumps. See this little bump, and this little bump. It's energy. Basically, now I started doubting if this result really can hold for a long time. Okay, so just a little blip. But they said that this little blip is very consistent, number one, and also matches mathematical creation. So that's why the word. Okay, so now my question is, okay, if you say you can use these two blips to create just let me finish the sentence. Now you are free to ask. Can demonstrate the existence of God's particle. So I said, what about the other blips? These other blips does not exist in current theory. They only created is called what is discrete particles, right? Actually, we have a continuous form. Can you turn one more page, and then okay. And this is another chart also included in the $9 billion cost to demonstrate God particle. So this chart talking about, this is electrons, and this blue line, long lines is muon. Muon basically is electron, is a higher generation with a higher mass, right? So my question is, that demonstrated, you have a God particle exists because we observe energy. So what about the other lines? You see the lines? Every single lines, I believe, is a charged particle. Charged particle created light. So that's me. I said, the fundamental particle smaller, billion times smaller than electron. However, it can create all the lines. Okay, then, yeah, what's your question? Sorry. Yes, we are. So, okay. So since this one, and that's a very legitimate question. I do have a question and answer. Can we just, because I have some questions embedded in this one. So can you just flip those one by one until I said stop? Oh, stop this one. Okay. This is a question I know Jason, that's my colleague mate, okay, very smart man. He mentioned about it. He asked me, electron, everything about the electron. I told you about the electron. Electron is nothing more just a magnetic particle. So I want you to play, can you play this video? Click this one. Oh, and do not click circle. Yeah, okay, got it. This is the magnet. He removed the magnet. You see the lines. Goes back. Yeah. Now in horizontal, this is a vacuum tube. Did you see this? He used a magnet rotating. The line rotated with him. Demonstrated electron has a magnetic pulse. There was a magnet down there. When he lowered it to down, you know, all the magnetic field goes down with him. Now he lifted up, goes straight. Okay, you can stop now. This is another page show when you have a particle accelerator, you have a billions collisions at the same time each time. So what they did is they ignore everything else, only select something out ordinary. Okay. So my argument is the stuff you throw out, they are all generated by particles smaller than what we know. I think that's not junk data. Actually, that's a proof there exists some kind of charged particles smaller than electron. That's my argument. Okay. Light. Too bad I do not have time to tell you the light, but I just summarize what is a light. Light is a vibration of magnetic particles in the medium, okay, entire space filled with called this fluids. That's what the dark matter says, right? We're missing matter, right? Yeah, it's a field with this. Okay, so wave. Yeah, this is the best piece, but I cannot tell you, so I have to jump this one. If I may just spend couple seconds, couple minutes on this one, it's so important. I think that's why Pat, my ex director of the engineering NE, he was impressed when I showed him. I said, if you look at the lights, I said, use this laser pointer. Everybody can see this laser pointer. I said, if light is a particle, I said, you imagine how many particles can be seen by everybody at a different distance, at a different angle, can see at the same time, constantly. He instantly, he doesn't know, his face lit it up for me. Oh my God, that's called a light, So, you have the room full particles. in order to come out of this little reflection of a laser pointer. That's why I said it's impossible. That's the trigger of entire new discovery. Since light cannot be particle, so what is light? Light has to be wave. So what is a wave? Wave require medium. That's what we current theory say we call the vacuum. Okay. Sorry about it. Again, sorry. I wanted to say, what's the difference, size difference? I give you the size difference. I said, what is the size of this UON, universal magnetic particle, relative to electron? Okay. Electron is minus E minus 18, 18th power. 18th power, that means billions and billions, smaller than, it's basically billions times smaller than new atom and molecules, right? I said that this universal magnetic particle is e to the minus 35th power, less than electron. It's billions, it's 100 millions and billions smaller than electron. So so what happens? It forms a sea of magnetic fluids. So all the electrons is a very significant size. Electron and atoms is basically we are soaked in the oceans of this particle. Okay, so with that one, I hope I'm not gonna non-stop. Oh my goodness. LED lights, I can't resist. Sorry that I cannot resist this talk about what is the principle of LED. My son told me, Dad, you should buy Christmas lights, new Christmas lights. I said, we have a bunch of them. He said, oh, you should buy the LED. I said, why? And he said, because LED does not generate heat. I was surprised with this kind of physical answer. Okay, I would expect save money or more efficient. He said does not generate heat. So so at the time I thought it's impossible. How could light does not generate heat? We know electrons go through wire. What is electron? I said the electron just a magnet, right? Magnet so-called goes through wire. Actually, is oscillating. Electron and plus the atoms is oscillating, right? Generate light. You don't need to have a closed circuit. I said, how can oscillating, vibrating, how could that not generate heat? That's impossible. So, okay, yeah, sure, you answer. Oh, okay. Okay, so I ate my word. So then I'm gonna skip this one, even though I really attempted to. Okay. Okay, this is almost 200 pages. Can you, I'm asking the people operating this one, can you stop this one and search keyword question? No, not just question. Put a little symbol called the @ symbol and a space and with a Q. If you can exit this window. Yeah, and search keyword. You search keyword. You put a little @ symbol, and with a space and with a Q. And so it will, because it goes through the 200 pages. I definitely the 10 minutes that's not enough. Yeah. Oh. Okay. Okay. I think you saw, I saw the symbol of a question. If you can just go back a little bit, go back. Okay, yeah, there you go. So this is the page. Yeah, that's correct. Okay, so Marv. Okay, so now let's keep moving, yeah. Okay, that's the questions, Okong, so I will tell you. So we have a priority here, so I will tell you later. Okay, so let's keep going. electron orbit at the speed of light? Okay, that's Dan's question. So I know he couldn't wait, yeah. Actually, I appreciate your question because your question do make me think. But one question is, during the last meeting, I mentioned about things, electrons was originally proposed circling orbit at the speed of light, and so then challenging me. Okay, sure.
I don't believe that atomic theory requires the electron to orbit at the speed of light.
Right. Yeah.
It makes that assertion.
Yeah. I'm not disagree with you. So basically, if everything operated, at the speed of light, right? We're violated theory of relativity. However, we do have even quantum mechanics. They say they do see sometimes the electron. They do assuming if there is no called Gauss particle, they said the electron will be zip around at the speed of light. They said that the reason the Gauss particle is a provide mass, basically provide resistance, slow them down, Yeah, that's part of it. So basically, what I did, I thought, when Dan first asked me that, when I thought, maybe I'm so old. When I learned, so my, professor, taught me, say, speed of light. But now I found out that this term has been used quite loosely. It's a near speed of light. So maybe 90%, or
Excuse me, the position of an electron around an atom is probabilistic. It doesn't perfectly come on it. However, there is a procedure for calculating the average velocity.
yes.
And that procedure shows that in a typical atom that the average velocity of electrons is about 1% of the speed of light.
Yeah, I just about to say your.
As a result, there's no detectable increase in mass.
That's okay. Yeah, I'm not disagreeing. Basically, he said actually it's not circling at the speed of light, but it's still circling, right? So say 1% or 0.1% still circling. It does not undercut my argument and say there is nothing circling. I have so much evidence. I do not have time to demonstrate. So you can feel free to walk to my office. I will demonstrate one by one why everything is okay. So let's go another one. Rutherford Goldfoil test. That's another dense. I did do lots of work, okay. I just don't want you carried away with something I ignore. No, I take every criticism seriously. Okay, and this is not even criticism, it's just a question. Said Rutherford foil, so it's a long question. Basically say, we have so many experiments that demonstrated, there is no Rutherford. Oh, okay. Rutherford experiment actually is demonstrated atom is most empty. It's 99.9999% of empty space. So that means electron to nucleus is empty. So we have lots of evidence. Have experimental. Let me just tell you what I view this one. Yeah. So the experiment demonstrated, say, this is what we expected. Initially, we have a model. That's the Niels Bohr. This is Rutherford. Rutherford's the PhD advisor. PhD advisor proposed one model. J.J. Thomson's called the plum pudding model. Basically, atom size, nucleus size is atom size. Electron stick on the surface, stay stationary on the surface. That's basically my theory says. That's actually, it was correct. Not absolute correct, it's a largely correct statement, being overthrown by his student. That's a Rutherford, with this is called the famous Goldfoil test. Okay, let me see if this one's still working. Okay, so here's what I view. So this side is what is supposed to be current explanation. Say the gold atoms. They think about it. The gold foil is so thin, almost in a single layer gold atoms. Okay, so they said the only thing when they shooting the alpha particle is most of them passing through it. If you see, this particle and particle are connected. See, are singularly connected. So why we have a spacing passing through it? And say 99 point, I forgot what is 98% of passing, only occasionally being bouncing back. That's what they tested. And see what my explanation with the modern technology. This is the gold atomic imaging I digged out with one help a chemist. I don't know if he was here. You see, it's not closed packed as we predicted, as we expected. So which means most particles will pass. But why that high rate? Based on this one, you may not be that high rate passing, right? Remember, the test performed by alpha particle. Alpha particle is a helium particle, is a charged particle. You think about it, when you direct a charged particle in a magnetic field, we know any magnetic field, if you have a south, you will have a north. With this kind of complex matrix structure, when you're shooting magnetic particle, it will be direct. When the south and north in the balance point, always, I would say 98% of the time, it will direct in the neutral. Neutral is empty space, passing through it. That's my person. Nobody in the world, in the world, say what I say. Most of the stuff I say today is only my own. Does not represent Pat. That was the director of GE. Does not represent NASA or U.S. government. Okay, so most of it is only my own opinion. I will take whatever response. So that's my explanation. So even this result. Okay, just give me 1 second. Even this result took Rutherford 2 years after the experiment. 2 years struggling, come out explanation. Apparently he has a competing theory. Okay, then now you can question. Right. My explanation is magical magnetic field direct, because that's charged particle. If you use a neutral particle, I'm guarantee you use a ping pong ball, they will bounce back. If you use a neutral particle, it will bounce back. So, the test will be different. So now I'm challenging all the physics in the world. Test this one again. If you can use a neutral particle. But I don't know how they drive a neutral particle, because in order to drive them, they use a magnetic field, so it's challenging to them. But, I know a human mind, unbelievable. So I think I have another, dance, it's all about the dance questions. Okay. Okay, so this is another dance problem. So then if you just patient, because you were right, otherwise we run out of time. You see, I didn't spend all the questions started with your question, okay? I do respect you intellectually, okay?
Well, I just want to explain, because I haven't used the scanning atomic microscopy, but related technique called atomic force microscopy for a number of years, and I'm fairly familiar with it. It's a solid technique, and these images do show the active presence of molecular orbitals, whereas
Yeah.
your theory would say that
I agree with you. They do see, include this paper you forwarded to me, right? Okay, so you already set up a background. Everybody they do see the orbitals. So now I try to say, what is the orbital they see? Okay, so this paper, published, I forgot which year, 2011, on this kind of Nature magazine. This Nature magazine is world, if not the best, one of the best, scientific magazine, journal in the world. They only select a paper has called earth-shaking, groundbreaking, publication. That's the one. So they selected this paper. They called the first time observed in experiment called orbitals. But the problem is, you see, okay, it's earth-shaking because nobody ever observed that there's orbital available. Earth-shaking, but there's a little bit of minor detail kicking me about the author who get published on this journal just like a win Olympic gold medal. Okay, so people will try their best, or even more than their best, to get in. Okay, so now let's see. First of all, they said orbital imply this is the orbital of electron. I cannot find the word electron there. What they said is orbital of molecule. You see the parsing words. So I said, wow, are you talking about orbital of molecules? So could it be the orbital of vibrating atom, right? I cannot find the word, where is the orbital of electron? It cannot come out. Another thing is funny to me. They do not have a scale labeled. Make it so difficult. You have to read the fine print in order to guessing. What is the scale we'll see? Okay, so I just say, assuming that's all correct. So what do we see is, this is basically in the nanometer scale. Nanometer scale. So this is kind of two type of orbitals. You see, this kind of orbitals, and this is a computer model. It's so strikingly, for me, it's amazing, perfectly match the computer model. Okay, I'm not saying I'm doubted this one. I did a little bit suspected that one. Okay, so now let's say use logic. This is a nanometer. This is a nanometer scale. I told you what is the electron scale. Electron is another billion times smaller. Electron is a billion times smaller than any of this contour they call the orbitals. So basically, electron is invisible. So does nucleus based on the quantum mechanics. These are invisible. So what are we really see here?
Well, what we're seeing are the probabilistic fields that the electrons occupy at time.
I know. That's a perfect explanation. He said this is a probability field. Probability field only one time at a time. So when they took this picture, that's one time, right? So why it is displayed the entire field? Tell me.
No, the image is time average.
Time average. You mean this is a superposition image?
Well, yeah, I mean,
That's called manipulation. You give an image, you add one time.
yeah, it certainly wouldn't be possible to image electrons.
Oh. You know, Dan, I do not believe your answer is correct. I'm sorry. Yeah. Okay. So basically say this is impossible based on the current theory prediction. It's invisible. It's a probability field. I agree with that. That's the current theory say. Everything is a probability field. How could the probability field can appear at same time altogether? That means the electron has to be at that moment occupy entire field. Dan, do you have an explanation? No, I'm sorry. I thought you were raising questions. I want you to, when I ask questions, I want you to answer my question. So.
Yes, actually, the electron has varying probability of being at any location.
That's current explanation. Yeah, but why we can see them at the same time? Do you believe electrons same time can be multiple locations?
The electron doesn't have to be in multiple locations. This is, as I say, any kind of image that you get of a molecular orbital is going to average the
Oh, so you mean, okay, thank you. I misunderstood. I thought that this is a real image test. So this is thank you, that gentleman. Okay, I could not believe it. I'm gonna contact this editor. If that's one, that's called academic cheating. If you are not image, this is not a laboratory image. It's a super imposed. I thought that's called cheating.
In fairness, there's nothing there that says that that's an image of an electron.
So
You have a molecular orbital, which is the average position of the electron over time.
okay, I agree with you. So what is the image then?
Actually, it's a representation of the force of the volume of whatever that orbital is. Because what you're seeing there isn't actually reflected light. It's every little bit of light you see there is a repulsion force. Because you're physically moving a little probe away from the source. So what you're seeing is I guess a time-weighted average of a long duration exposure
Okay.
of a bunch of test points.
Yes. So this gentleman answered slightly different. He said these are the light's reflection of electron.
It's not reflected
The force.
force related between moving probes.
Oh, so okay. Let me slow down. I'm slow here. What I see is, in order for we image it, we see is light, right? So everything we see is light.
No, they're converting a force into a shade of light or dark. Wherever
Oh,
Brighter is light. Where it's brighter, it's more force.
okay. So you said that this is not a real. Okay. So you thought that this is not a real image. This is a created image based on the magnetic field, force field.
Yes.
Okay. If that one still is academic cheating, if that's the case, that advertise that this is called orbital. Is image, so that's what I got it. Unless I read it, I'm being misled by so this is not image. So this is not experiment. This is artificial creation. Oh, that gentleman.
To be fair to the author, every picture ever taken is at the time average.
Oh, it's time average.
There's an aperture time, maybe millisecond or however they can get.
Oh, okay. Okay. So he provided explanation. Actually, that's the answer I was waiting for. Is to say, assuming electron at that moment, that when they take a picture, they have a split of a second, right? Second moment, zebra around every single possible the probability surface. Then when we see it, it's basically reflection from all the at the same time, just electron at every single state. So now, okay, I know this is the answer I was expecting. So now I question you. This electron's life is so hard. It can be at a just split a second everywhere as predicted by the orbital. Oh, I thought my life is hard, so I don't want it to be an electron. So, okay, let's move further. Okay. Okay, so this is another dense question. So all the 10 minutes donated to your question. So, okay. So this is called Michelson. I use sometimes called Michelson. So, and the Michelson-Morley experiment demonstrate that there is no ether exist, right? So, let me see if I'm not have the time to play the video, tell you what is the test. Michelson. I just tell you the results. Okay. Number one, this experiment, the Michelson-Morley experiment, called the most famous field experiment in the universe, in the world. This is the most famous called field experiment. I copied this word from the page. Okay, so why called field? Designed to detect the ether, and failed because it did not detect ether. What happens? Years later, this experiment being used as evidence of there is no ether. Okay, of course, there are so many other tests. I listed everything. Google, Wikipedia can list it. So many different experiments. I listed. They have a common thread. This line is called this is an armor length. In order to detect the minute light difference, because Earth's rotation different in different direction. In order, so they use armor length, longer length, and this is the results, expected results. They have certain expectation in their mind, and then they have a measurement. This is the measurement. So they measured. They said, oh, why the measured is different than expected? Called this ratio, this rate. So they said, why the measured, differ than we expect so much? But if you look at the common thread, every single measurement, they do have a positive number. They do not have a zero number. They do have a positive number, but just because of this positive number within their tolerance, so they throw it away. Okay, sure. Yeah, that's the best estimate that they come out, right? Statistical number. So we still have a positive number, but just less than what we expected. So basically, what I said is, and then if you look at it even further, I highlighted the two red. Later example, they called unclear. And then I check, okay, why these two called unclear? If you look at the arm length, they use the 32 feet or meter. Oh, 32 meter. This is the longest. The original test, Michelson-Morley test, is only 1.2 meter. only 1.2 meter long, on little dinner table, circular dinner table. So I do not believe the accuracy is that enough. Okay, I do not have that time, so let's move on. Orbital electron, oh, I'm going backward, sorry. Okay, I'm not gonna go through every single questions, most of them go through. So I'm gonna open floor. Whoever want to ask any questions, you're free.
I recently saw where a group from Amherst had isolated a monopole.
Oh yes, yes. I'm Daniel Cyril. I do have them here. Oh, I forgot. So the monopole. Thank you. I do not know if Gabrow's here. He sent me the monopole paper, also published by this paper, monopole. Can you antimatter monopole? Oh, magnetic monopole. Let me see if I miss the magnetic monopole. Yeah, Dirac equation. Yeah, I do have it here. I wanted to discuss that one. If you can run down, sometimes. Oh, there you go. I think this is the one. Oh, thank you. I wanted to answer those questions. There's one gentleman mentioned about the magnetic monopole, because in my theory, everything's a dipole. There's impossible to have monopole. But why there's a paper still published by this Nature? The only published Earth shattering paper. They said laboratory detect called, okay, use the correct word, synthetic monopole. Right? Yeah, he agreed with me. He does not even have a ball to say this is a monopole in the world. Has to be put adjectives. And I said, okay, that's good. Sorry about it. Sorry about the language. I said, that's okay. Tell me what you did. If monopole exists as a fundamental form of universe, because I can create a synthetic form. Let me show you what is a synthetic form. Can you turn one more page? Another page. Okay. I have no problem create a synthetic monopole. Synthetic monopole say magnet. If we say, see this one, this is all positive north pole on outside, or south pole on outside. I have no problem. This is if you wanted to create a condition. Under certain condition, make it looks like a monopole. I have totally no problem. But I believe the paper, the editor, published it, truly believe he made some earth-shattering discovery. Something exists in nature. But when I go through it, you read this one, unbelievable. That's the signature of the what is called a Nobel Prize winning paper. No human being can understand a thing about it. That's a requirement. If you can understand that, you will never win Nobel Prize. I should not say never, okay? Because I do know one gentleman here. He almost won his Nobel Prize. He just left. I'm sorry for the meeting. So basically, it's humanly. When I read it, humanly unexplainable, so complicated. The picture, I just saw you, I put the picture there, so complicated, and created in the vacuum, in the laboratory, in a tube, only at that second. Okay, and in the same paper, I still listen, the same paper, listen here. See all known magnets have a north and south pole, okay? All known. Here say, break a magnet compass needle in two, for instance, and there will be always two smaller magnets with both poles, the paper. Okay, and say you can slice up your needles as much as you like, and you can even get down to the atom level, and you will still have a north pole and a south pole. And so what else here is, Oh my goodness. Oh, okay. This is the, so where comes this theory called the magnetic monopole? I have a ex-NASA here. That's Dance. I know Dance wanted to say. Let me say if I said what you said. This is a creation by Paul Dirac. Dirac equation. He is one of the most famous founder of quantum mechanics. Dirac. Let me tell you one thing. I do not believe anything Dirac equation predicts. You know what is the Dirac equation? Dirac is the first one used to reconcile Einstein's theory of relativity with quantum mechanics. So what his model, if you look at his equation, is identical to E equal to mc squared. The m with inverse term in the numerators. Anything come out of that one. So I do not have time to go through what's wrong, fundamentally wrong with theory of relativity. I do not have time, so I cannot convince you. Anything come out of that equation, I do not believe anything. Let me tell you, he's not just predicted this called monopole. Monopole. He also predict antimatter. I do not believe antimatter exists. Okay, then, tell me. Why not?
Well, because the lines of force still around the North Pole and South Pole.
Right, but when you have a charged particle travel in this direction, you will get attracted.
No, the North and South Poles are still going to exert force on another magnet to be separate from that.
I agree with you. Yes.
Just as though they
Yes.
use bar magnets, et cetera. The other point I'd like to make here is that in your previous presentation, you showed a slide that said that the interaction between magnetic dipoles decreased with the inverse square.
Oh yeah, I remember that one. Yeah.
And in fact, the attractive forces like the electrostatic force and gravitational force, they do obey the inverse square law. The force between magnetic dipoles does not obey the inverse square law. It decreases roughly with the fourth power of it. So it's difficult to see how an interaction between dipoles.
Oh yeah, sure. Sure. Yeah, this is another question. Probably the last question that he mentioned in that list is talking about. So when I pulled Coulomb's law, okay, Coulomb's is called electricity. Law of static electricity law. Coulomb's law has identical form as Newton's gravitation law. Is inverse. So the force. Inverse proportional inverse to the square of the distance, right? Yeah, that's Coulomb's law. In my mind, Coulomb's law, that's a magnetic field, electromagnetic field, right? And for me, it's the same field, right? But he's arguing, he said, okay, even so, he said, why I take a Coulomb's law? I did not take called a magnetic force. You have a dipole magnetic force will show you a different type of law. Yeah. So, okay. Yeah, that's fair. That's fair. So even though I'm comparing Coulomb, I consider Coulomb's law still valid, right? It's not like a fake law. You cannot say Coulomb's law is wrong, and still identical to the gravity. They are the same, exactly the same form. So mathematically, they are same form, only different by one proportional. I had that prepared. Too bad I did not put it in the question section. So let me tell you what that law says. That law says when you consider the force, when the particle senses the force from other object, can be approximated to a point source. Instead of a near field. In the near field, you will have a nonlinear effect. So that's what you said. Oh, with a nonlinear effect, it's dramatically reduction. Of course, I'm not smart, okay, but at least I can tell. What's the difference between near field and far field? So, and I look at the condition. We consider gravity is far distance. So that's why we consider Earth's gravitation versus the sun as a point particles, right? That's what Coulomb's law assuming. If you have assuming that's a point particle, you will have that. If you have a dipole, If you so near field, now we have a negative and a positive dipole, you will have a different view. Okay, let me see if I can move further. Oh, this is another good things. Okay, this is my last question I wanted to answer to that gentleman. Magnetic dipole. I think a magnetic dipole is impossible. In terms of if it's a fundamental term, it cannot be fundamental. This is my demonstration or called a proof. How do I think about it? If you look at a magnet, this is a dipole magnet. Anytime you cut it in half, still maintain the same property, right? Still same property. So now, and then the process is reversible. If you combine any two magnets, you combine them and then they become one magnet with a larger north pole, right? Reversible. What about if you have a fundamental particle? That means property cannot change, okay? If you have a monopole, you cut it in half, right? Based on the assumption, we still have the same property, right? Still the monopole. And then cut another half. Now, my question is, can this process is reversible? Can you say put the two monopole together, become one bigger monopole? If you can, you violated the fundamental law of electricity, like pole repel. You cannot. What that means, if you not